It's an honor for me to be here with you guys. It's my first connection with James in this session. I'm gonna hold the camera until I present myself, and then I'm going to switch it off if this is not a problem, just to save bandwidth. Things happen in live workshops, so let's be on the safe side. Few words about me. I'm Konstantinos Passadis. I'm calling from Athens, Greece. I'm a solutions architect. These are my details. I'm quite an information technology professional geek. I have 20 years more of experience. I have been introduced to cloud, Azure, and other technologies as well. I work a lot with many different technologies. Lately, I started work with data, AI, and all that good stuff. These are my URLs. You can find me on LinkedIn. I have the code in GitHub, as well the code of this session that we're going to show, and my blog is here.
I've just noticed
So,
you got four expert level
yeah.
badges.
Yes.
Wow, that's hard work.
Yes. Yeah, in the last years I have been into certifications a lot, but then I realized that it's not only about certifications. It's good to have certifications. You learn a few things, but it's better to have the hands-on, and the read. This is the curse of our profession. We have to be always reading and catching on new things,
Yeah.
Yeah. So yes, I want to thank again James for having me today. I'm really excited for this session, guys. This is an idea that I had on my mind a lot of time ago. I didn't, had the time to make it happen, but finally I managed to make it happen. So I will be very excited to present it to you. So what we are going to do? What we're going to do? We're going to build, in fact, an Azure SQL that is going to hold our user information. It's going to be a custom identity database. Azure SQL database. It's a great resource. We could choose the cheap tiering. We don't need too much, especially for this workshop, but we can scale it up if our users grow. We will have also the registration UI and the login UI, and then the users will be taken into a dashboard, which I added a little treat for you guys. The dashboard is a search, I'm sorry, a text box where someone can set a question, and the question is sent to ChatGPT. It's only about SQL. ChatGPT will answer only SQL related queries, and the response will come back. So this is a little addition I added in the last 2 days just to see the whole solution and the possibilities we have with this dashboard. Our solution is built with Terraform. Just to be safe, I have already built the solution because I have noticed that propagation and some provisioning takes time, especially some core settings. I have seen that it takes some time to finally, get done. So for us to not lose time, I have already built the solution, but I will build it again with you now, and we will see what happens. I'm using a remote desktop on an Azure workstation, and I have my VS Code on. So I have created a root folder. It's named Search App. The initial idea was to create a search application with Azure Bing Maps, but I changed my mind and I have added ChatGPT and these questions about SQL. So this is the subfolder, React Search. I have the backend folder, which is a Node.Express web application as well that will hold our API endpoints. Our routes will go to this backend from the frontend, which is a React application, a React web application. This is the main folder. Anyone who have worked with React will understand the directory structure. We have the SRC folder that is holding the main files. JS is the extension. Here is the main content, for example, and we will see this all in our screen later when we build it. All these two applications, the front end and the backend, will be containerized with the help of Docker, pushed to Azure Container Registry, and then create a new web application for each one of them. Now, in regards of security, this it's a whole new chapter. I will try to add some things at the end. It's really important to keep that in mind that this is not a production environment because it doesn't have all the security features that we should have. I will mention the details that are needed, but not everything is here. We are here to see how, not the little details about security or the big details, I'm sorry, about security. So let's go to Terraform. Terraform is using the main file that contains all the descriptive code for our resources. It uses a module folder that the module is about Key Vault because Key Vault plays a very important role in our infrastructure. It holds almost every secret that we use. For example, it holds the SQL admin username, the SQL admin password, the server name, the database name, the storage account name that we use to store our photo, because the users are also storing their photos, they uploading their photos once they register to our identity system. It's holding also the connection string and a JWT secret that is used for authentication. When the user authenticates, the JWT token contains as a payload the user ID. We will see that into our code in the Express application. I'm sorry. You will see here that Terraform is quite flexible. We can create even the table into our SQL, and you will see into the main file how we'll do that. I have already here my script. It's a .SQL script that does this very simple thing. It creates the table, but whatever we can do to save time, we can do it with Terraform. The tfvars file that is holding our variables, the variables tf that we declare our variables that we're going to use, the providers that we tell Terraform which providers is going to use it, what files is going to download, the packages, and the main file. I'm creating a random string here for randomness into our names, a log analytics workspace, application insights, very useful if we want to troubleshoot, our SQL server. You see here the randomness that we're going to create. It started with a prefix SQL and then a random string that we created earlier. A login and an object ID because I want to be able to log in with enter ID also. Public network it is enabled. Firewall rule, it is important to set this because we want to log in from wherever we want to log into our SQL. We can narrow down, of course, this, and I will explain at the end if we have time how we can do that. The SQL database, basic license, it is the cheapest tier on Azure SQL. And now the local provisioner. This is how Terraform provides us the ability to create something different than just a virtual machine or resource group, something more complex maybe or a little bit deeper. So what it does, it is as it's called a local provisioner, and it is used to create our SQL table. What it does, it runs just a simple command. This is the command SQL get the SQL server name, get the SQL admin username, get the SQL admin password, and run our script. This little script that we saw earlier. Let's continue. We have our storage account. I can set the core settings right now in the Terraform, so I can save also time and not go there by hand and set the core settings. It is needed because we are calling from a web application to the storage account, and if we don't do that, we will get an error. We can create our storage container that will hold the pictures of the photos of the users. The access type is in container, and we create a container registry that will push our two images that we will create from them, the web apps. I'm outputting the container registry name. I'm using also a user assigned managed identity that will have the roles that we need to assign to the backend so it can get the secrets from Key Vault. I will show you again how we'll do that. The contributor role, the DB contributor role to the user assigned managed identity that will be assigned to the backend again, because we need to be able to read and write from the SQL, because the registration happens from the backend. The Key Vault module, and again, here is our Key Vault secondary Terraform file. We are creating a new key vault in the standard tier, and we are activating RBAC authorization, not access policies. We're using the newest model, which is RBAC authorization. What we do here, we are outputting the key vault name. I'm not sure if we will see it because it's a secondary file. Don't worry about that. Now, we are assigning a role. The role is assigned to the service principal that it is used to run the Terraform configuration towards our subscription. So imagine that this is the application registration. Okay, it is a service principal, and with this, I'm using it as a contributor to run towards my subscription and be able to create these resources. I will also need this role assigned to the service principal so it can assign other roles as well and create the secrets. I'm creating this role also, the secrets officer, and this is done because I want to write the secrets to the key vault from the service principal, and I'm assigning the secrets user to the managed identity that is going to be tied with the backend endpoint, the backend web application, because user just reads the secrets. We just need to read the secrets. And the secrets is the SQL admin username you saw before, the JWT uh, secret, and the SQL, the storage account name, the SQL admin, the database name, all these little details. So what we have done with this, we are able to not to include sensitive details into our code. Everything is stored into Key Vault, and our backend just communicates with the Key Vault and gets these values. This is the backend, okay? The Node.js Express application. So what we do here, let's go to the important stuff. We're creating a Key Vault client. We are utilizing managed identity, not the system assigned, but the user assigned managed identity. In case this causes trouble or it's getting late to work, we can switch to the system assigned managed identity, and we can save time again, as I said earlier. We are creating also our SQL configuration in our SQL details here. We are telling to our endpoint, get the secrets, these secrets from Key Vault, the storage account and the storage account connection string. Everything is stored from this Terraform configuration directly to Key Vault, and the JWT secret. The JWT secret, uh, what is done? When a user registers and then tries to log in, the web token, a web token is generated using this JWT.sign. Let me show you where we can see it more clear. You can see here that the detail that grabs the photos, and here is the important stuff. This is the endpoints that we create. So everything from the front end is calling these endpoints. In front of here, we have the URL of the web application, and this is the endpoint. In fact, everything we can call it an API. We can call these endpoints our little APIs that the front end calls to our backend. So we have a lot of routes here, a lot of endpoints. This is the upload photo, where it's used to upload the photo to storage account. This is the registration endpoint. The user registers here, also uploads the photo. We need this line to write the photo into the blob, into the container as a blob. And here is how it writes the details of the user into the SQL database. And here it's the login endpoint. You can see here that we have these lines that says if the password is not valid, return a 401 message that is invalid. And if it is correct, what it does is generating a new token. The token includes the user ID as a payload, and it is signed with a JW secret that we are creating into our key vault. It has an expiration of 1 hour, and the generated token and the user ID are sent back to our client. The token is typically used by the client for authenticated requests, all the requests that you saw earlier to other routes in the application. For example, when we will execute the into the dashboard, the Ask GPT part, we have to be authenticated into our application. Okay, so this has 1 hour. Um, it lasts for 1 hour. This is the user ID endpoint because we are bringing into our dashboard the user details and the query that we execute against OpenAI. I'm using an organization and an OpenAI key. All these details are stored as .n variables. I'm going to change this when we create our resources. And this is the way that we construct the prompt. We're telling him that you are a helpful assistant that answers questions on SQL. And the query comes from the dashboard, the text box that we're using. Let me show you real quick the front end, because you have to understand what's happening there real quick, because it's a very big application, the web application of created into React. The important part is here is the dashboard. That is the last screen that the user gets once it is correctly authenticated and logged in. This is the dashboard that he gets. So what happens here? You can see that it's using the token and the user ID to keep the user as an authenticated user into our app. And here is how we are sending the query to the ChatGPT with the help of our little API endpoint. In case something wrong happens, we get this answer back. Error control during query or while processing our request. It's good to have a good error control because we need to understand what's going on if we need to troubleshoot something. And this is the classes that we're using for styling as well. And here is how we're constructing our query that you saw into our endpoint. Okay, the data is called the query that we're getting into our main endpoint here, the user query. Okay, some configuration that are sent also to GPT. And this is the extraction of the response that is presenting back to our front end here. Very easy to create this one. A class with a response, just to give a little bit of a styling for our front end. So let's continue and start creating. What I'm going to do, I'm going to go to the folder that holds our Terraform configuration. I need to find the Terraform configuration. So it is the React search and it is Terraform. The first thing that I have to do is run the Terraform init that initializes our Terraform configuration. It downloads all packages that are seen into the Terraform providers file. Let me also show you in the left what's going on. It's creating this folder, as you can see here, the Terraform folder. And it is ready. Now I can start deploying, but it's good for us to run these two things. The first one, it's just for indentation, doesn't change nothing, just brings our contents here into a correct order and visually it gets better for us and we can understand what it is written. And Terraform validate, very important. Before we deploy anything, it will inform us if something is wrong we forgot something or our code doesn't make sense. It seems that we are okay with our code, so the next thing I have to do is the Terraform plan. Terraform plan doesn't deploy nothing, just creates the blueprint of our deployment. So when it's run, it will inform us what is going to happen. The plus icon on the left means that it will create a new one. So you can see here that it will create all these resources that I showed you earlier. Every configuration is shown as a plus sign and the line that contains the details that we have written into our main.tf file. If we are happy with our plan, we can start deploying and the command is apply. Now, if I run this Terraform apply, just this, it will rerun this plan and will ask me, do you want me to deploy? And the only accepted input is the word yes. If I'm very sure that I'm okay and I don't want this approval step, I can just add this auto approve. So we're firing our Terraform and we should be able to see what is happening. Now, guys, if I am saying something that doesn't make sense, please ask me. I will do my best to answer your questions. And I'm not a native English speaker, so if something is not understood, feel free to ask me. I will try again my best to explain. So we will be able to see a new resource group here from moment to moment. Also into our screen, we are getting all the details of what's going on with our deployment. I have to warn you that we may see an error here because what we are trying to do is to add the roles to our service principal into the key vault and then write into the key vault the secrets. There is a case where maybe the roles doesn't get quickly propagated, it doesn't get quickly updated the Azure portal, and we will get an error that I can't continue writing your secrets into Key Vault. This is not a problem. We will run again apply, and it will not change nothing. It will just continue to deploy what is left, and it is not deployed. This is the beauty of Terraform. I just can add a line here. It will not redeploy everything. It will just add the changes. So in case we see the error, we'll just run again the apply. Let's see if we have our resource group here. Yes, the resource group is created. Let's go and see what's created. We have the application inside. We have the container registry. Here we will push our Docker images for the frontend and for the backend. The key vault, the local analytics, of course, our SQL server, the storage account, and the user assigned managed identity that we will assign to our backend to perform these operations with SQL and read the secrets from Key Vault. Let's go back and see what's going on. As I said earlier, I have already a deployment ready. In case we face any trouble, we'll switch to the pre-provisioned resources to see our solution. Now, I don't know if you have used Terraform, guys, or if you are familiar with this. I was scared. I was very scared to use it. I was more into JSON templates, which are already deprecated, and Bicep is coming and taking over. So I didn't know what to do, if I had to learn Bicep from scratch or if I would give it a go with Terraform. And to tell you the truth, I'm not a developer. I found my niche with Terraform. It is a great tool. It is very I will not say easy, but it is very understandable, especially when you are just starting. And if you are into infrastructure as code, you will love it. You will love it because it will make your life easier. You can do great things from the perspective of infrastructure deployment. and of course automation. You can achieve great levels of automation and make your life really, really easier, even as a professional, and not only into your demo projects or your learning projects. You can use it in your work, in your everyday operations, and you will see that it will really save you time and it will urge you to learn new things. Now, this is what I was telling you. The it says that here that you are not authorized. What I will do, I will just run it again or wait a couple of minutes and tell him, okay, no worries. Run again the deployment and create our secrets. The problem is that the service principal that is used to build this configuration got the correct permissions, but they are not yet propagated. So it seems that it doesn't have permission to create these secrets into Key Vault. This is the problem. It will overcome this, not really a trouble. We can continue and let's start creating our Docker files. We're going to use Docker. I have already opened here my Docker desktop. You have to run Docker desktop before using Windows or have Docker into your Linux system. What we're going to create is two repositories into our Azure Container Registry that will hold our backend and our frontend. Let's do that. I'm going to switch here and let's go to the backend. It makes sense in this kind of deployments to start with the backend. Let me find my backend. Yes, it's here. Clear. This is our backend. It has our Docker file and the Node+Express web application that it is going to be used just as the API endpoints that you saw earlier as routes, presented as routes into our code. For example, this one, you see here that we are sending post queries. So this is how we have configured our code into our server.js file. Here we have our packages. In case you see an error when you deploy your app into your local environment, you just have to go and npm install the correct package. So what do we need to do now? I need the Azure Container Registry name. So let's get it. This is the name, AZRIIYFX. And I need to build my backend. This is the command that you use to build your images. It is docker build -t backend space and this dot. So I'm building a new image and I'm naming it backend. I have to be in the correct directory. Yes, I am. Let's have a look on our Docker file, of course. This is the Docker file. Okay, using Node 18. It sets the work directory. It copies this package files JSON into the directory. It runs npm install. It copies everything from my directory except what it is here in the Docker ignore into the Node image directory. It exposes 3001 port and it runs Node server to expose our application. In my Docker ignore, what I'm saying, do not load Node modules. Of course, I don't have to load all the module here because since we are running Node here, all required packages will be seen from these imports and into our image, Node will run them, install them. So let's build our backend. Yeah, I have to rebuild it because I need to add. No, I don't need this. I have to explain this. We have two files that are holding environment variables. For the case of our Node.js application, these environment variables will be added into the application configuration, the web app configuration, into the portal, to say it otherwise. But in the React case, which we also have an env file, this one, the environment variables will need to be saved into our app. This is because React works this way. I cannot set this variable as a web application configuration. Either I have to find another way to do it, or I have to um, package it uh, along with my Docker file and set it into my code. So for Node.js, I don't care about these variables. I care if I deploy locally, but if I deploy to the cloud, I just need to add these into my application configuration. So I can continue with my image regarding backend. Now I have to tag it. Tags are very, very useful. I can tag my applications and keep a versioning with this way. So I can build an image and then start making little changes and naming the application with our tags. And with this way, I can make small changes and have, this way a differentiation between my main image, my latest image, my version 1 image, or my version 2, and all this good stuff. Editor, II, YFX, YFX. There are ways to bring these names and these details into our code, but not everything is about automation when we make these sessions. It is good to see some things happening by hand so we can understand better what we are doing. So I'm just tagging my backend into the container registry with this tag, version 1. If I don't tag it, it will take automatically the latest tag. I think I'm okay. And now I have to log in into this container registry before I push it. The command is very, very simple. I will show you because I don't want to write it. It is this command. Log in into Azure Container Registry, and the name, you can find it with this command that is into our parentheses, list all the container registry that are into this resource group and query the name. So I can log in directly with this command and no need to try to find again the name or, make my life harder. This is the command. I can keep it and execute it whenever I want to log in into the container registry. Before I push, I have to log in. So now it's time to push.
That definitely feels like one to make a record of, making life easy.
Yes, exactly. Exactly. YFX.Azure. I could also, in this context that we are discussing, save these as variables and just run the relevant commands. But it's nice to see some things happening before our eyes. Personally, I like to see that when I'm watching another person's session, I like to see these small details that maybe make the difference and make me understand better what's happening. So I'm pushing now my build image that is tagged with the tag version 1. Yes, I think everything is correct now. Let me push it. It will not take long. Let's see what happened with Terraform. I think, yes, you can see here that we don't have now the errors. Everything was added. Okay. It is not a rule that this will happen all the time. I think it's happening in 50% of the time. 50% of the time, you may face this issue that you are creating secrets into Key Vault, and you have added the correct permissions, but didn't catch up with the permissions, so it thinks that you are not authorized. We just run again the apply, and we're good to go. Let me open also a new PowerShell and start working with our frontend. Now, the frontend, before I deploy, I need this URL. So I have to be patient and create my backend web app, or be sure that this name is not taken, and to save some time, you know, uh, build also the frontend, but it's not taking that much time. You'll see here that the push will continue very, very quickly. It's pushing our image, and it is pushed. What happened now? If I go to my container registry and refresh, I have a new repo. It is named after the image name. And if I open here, whatever image I build and push with the relevant tag, I will see it listed here. I have only one new image with a new tag, and this is the one. And this is the magical menu of the Docker registry that we can deploy directly to a web app. So I'm clicking it, I'm giving it a name. Let's give that name. Into my yes, and I need a plan. It will create by default a standard plan. Let's keep a little consistent numbering into the North Europe region. Now you see that I'm pausing sometimes when I'm starting to build, because we don't need to make a mistake here and start to rebuild. It's not that big, the images, but we don't want to make a mistake, so I'm just trying to be careful. So this will be the application name. It is a Linux application. I don't have to select Windows in our case, and I'm creating a new application service plan into North Europe, into our resource group, and create. So you see here, guys, that I can push a new image into a container registry and directly deploy to a new web app. This is very, very useful from Azure for us. I found it very, very useful personally. You can do it also by Terraform. It's a little bit tricky because you have to take the FTP username and create a webhook. It's not that complex and difficult, but it's not this about the webhooks and the Docker registry. We want to see the solution as a whole. So important details I'm choosing to show you from our deployment. And I think this one is quite useful for us to know that we can do this from a container registry directly to a web app. And now we have our web application. This is our endpoint. It will hold our endpoint. It is the Node.js. You will see here that I can assign the user assigned managed identity that I have created earlier. It has already the roles I need. I will show you that it does. And I need to add here the environment variables that we need to take from this file. We need the Azure Key Vault name with a new name. This file that you saw in my screen does not affect this configuration, as you can understand, right? So I need the Key Vault name. I can understand it. It's KV-IIYFX. KV-IIYFX. I think it's that. 1, 2, 3, 4, 5. Yes, I think it's that. And I need my OpenAI API key for our dashboard. Application setting. I have 15 minutes left, so I have to be fast. And let me take the key. Luckily, we have this solution ready, so we will see it in action. Don't worry. because course settings will take some time to propagate as well. This is the configuration settings I need, and I need to add also the core settings. Sorry, save. Yes, the core settings to accept every origin. I could have added here on only my frontend URL, but let's make it with a star. Everything, all origins allowed. Let's go back, quickly deploy our frontend. Search up, I think. No. Frontend. What do we get here? Yes, cd react search frontend. And this is into my search app. I have a lot of folders here, no worries. So let's build. What did I change here? What have I changed? Yes, this one. So I have used this name. I can save this file now and keep it because, as I told you earlier, React will not respond to configuration settings into our app. It will take these environment variables. So I can build also my frontend now. Let's build our image. I'm into the correct folder. Let me show you quickly the Docker file for the frontend app. It is quite different. Node again, copy all files into the app directory, set the work directory, of course. Run npm run build, and then we're using nginx to host here our React application. We have a web application, and we're using nginx and exposing from the port 80, but it is HTTPS. Web applications in Azure will find the exposed port and will use HTTPS. Don't worry about that. Don't worry about that. In case you have a problem with your Docker image, you can set the port by hand into the configuration settings. But I think most Docker images are discovered by web app, so you don't have to do that. You will find the correct port. I'm building my frontend app. Yes, let's build it. And let's wait a couple of minutes and start seeing what have we built. I will show you from the other resource group because time is taking over. This is the other resource group from the other subscription I have. Familiar, these are our resources. Let's sort it by type. I have the two web apps, the two service plans, application inside the container registry and the webhooks. Key vault, our user assigned identity, and you can see here that from Terraform we assigned these roles directly: key vault, secrets user, and SQL DB contributor. And our SQL database and SQL server. Into the database we have our table that you saw that we created with our little script. I can also continue here. This is not the user that I have for the SQL, but I can connect here, and this is my table. I have also some users. You can see here that SQL does not, from our code, we're not saving the password, right? We're saving the hash. This is a security feature. The photo URL, it is stored into SQL, and it facilitates our web application. When someone logs in, it will find where his photo is stored. Let's go to the important stuff and see here our application. Come on. And this is, I'm sorry, guys. This is the front end, right? I can sign up and I can log in. Let's sign up a new user. First name, Bedrock. Last name, James. Let's do it like that. I hope James doesn't have a problem.
No, that's good for me.
Sales and CEO of sales. a username, James. I will add a complex password. I hope it's correct. Yeah, and I can add my photo here. I'm a car lover, so I will add my car. And I'm going to register my account. It is registered. If you get the screen, it is registered. I could add other things to pop up a message, everything, but it's not this that I want. We just need to register. So I registered. And the password, and I'm logging in. And here is my dashboard. You can see here that it brought up my photo, my name. I can log out, a new icon. And here is the little treat I told you earlier. Let's write a question. Select the statement. And ask. And ChatGPT answers. I hope this is built. I
Very
think
nice.
I can stop right here. You guys saw what we built. This is our solution. Now, a little more details about security. What we could do here, we could add a private endpoint into our SQL, a private endpoint into our key vault, and make this web application the backend, in our case, this one, virtual network integrated. What does it mean? I have to go to networking and configure virtual network integration. What it will do, it will take a whole subnet just for itself, but when we create the private endpoints and create our private DNS zone, all communication will happen from the backbone of Azure. Nothing will go through Internet. This is a very important security feature. And the last one, for our front end, we could add the front door also. And then we can also create a private endpoint here and configure our domain, configure more security features like security groups, filter by origin or header, and all that good stuff. I'm very happy that I was able to deliver this. I think you understood what we did here. Everything is available into GitHub and from our blog. I'm very honored that James had me here tonight. Thank you very much, guys. I'm here to answer questions or discuss anything that you want. And James is driving now. He's on the driver's seat.
No worries, thank you. That was really, really good. I can see where you got your full expert level stars, because you know an awful lot about an awful lot. I'm intrigued with that car. Is it? It looks like a Ford of some sort. I couldn't quite tell what it is.
Yeah.
Yeah. Also a car person. My son is as well. Yeah, no, that's really cool. I could see things like this. You'd be like a learner portal, especially being as you can restrict the OpenAI to a certain topic. But just the ability to log in, log out, you could have anything. It doesn't have to be this kind of functionality on the front end. It could be an in-house application that you want to control access to.
Yes.
And you just put this web front end on it, and yeah, I was talking to you about it before, wasn't I? About I can see a use case for me for I've got a customer who doesn't want to be they don't want a Microsoft tenant. Essentially, is the thing, which is for me very strange. Like, okay, but I know how to do all the Microsoft tenant stuff. So having a front end like this gives me the ability to bring in resources from all different APIs from all different companies without
Yeah.
requiring the tenant themselves to have sorry, a client themselves to have a Microsoft tenant. That's quite cool.
Yeah.
Yeah.
It was very, very good. That I really enjoyed that. It was very fast, but we currently have a Python Flask Vue.js front end with some Mongo, and we use Docker containers to do that. But the way we currently do it is we will log up, we instance a virtual machine, we get onto the virtual machine, we copy all the source code, and we do the Docker build on that machine. So seeing how Terraform works is like, all right, okay, that's good. We need to learn some of that, because we haven't quite got to the point where we create the images first, and then push them up. So this type of technology, I was aware of Terraform, but it's really nice to see somebody actually just take see you build it, see you actually see some of the code behind the scenes, and see how the Terraform file, what it looks like. So when you deploy to Azure, how does Terraform does Terraform have access to?
Yeah, I understood what your question is. Let me show you real quick. What we need to do is this very easy thing. I'm going to open a PowerShell to show you. It's the very well-known command. It is this command, az adsp create. So with this command, you are creating an application registration. It's called the service principal. And you have to go to my service principal here. I'm sorry. Yes, this one. And into the command, you add the AZSP create. I think it's role contributor. You add the name and all this stuff. So this service principal is what Terraform uses to authenticate to Azure. And how it does that? With the help of these two files. This one is declaring the variables, but this one is the important thing. It has the secret of the service principal, the ID of the service principal. So in fact, Terraform is a contributor with the use of these two details. And of course, it needs the tenant ID and the subscription ID. I hope you got me what I'm trying to say. So I'm creating a new application registration. It can be done also with this command, AZADSP create. You can look it up. I don't remember exactly how it goes. You add the role, the name, and the scope of the subscription. And it is a contributor. Now this one is a contributor. You have to go here and create a new secret, new client secret. And once you get these details, you add these as variables into this file, Terraform TFVars. This one and this one. So Terraform is a contributor to my subscription, and from wherever I run it, it will find the tenant ID and the subscription ID and will authenticate as a service principal with this secret and perform the resources provisioning. This is how it's done.
If you're unfamiliar with Terraform, can you create in Azure the resources that you need and then ask, does Azure have any tools to export a Terraform script that will?
Yeah, this is really nice question. It is how can I say it?
Exports ARM templates, doesn't it? And can it do Terraform?
You can export configurations with the help of Terraform in the form of Terraform. You cannot export like a JSON. It exports into this format, like this. It will output like this, the configuration from Azure.
So I was thinking as a workflow, you could, if you were playing with Azure in the Azure portal, think, oh, we'll have one of them and one of them. When you arrive at a solution, could we then go, okay, I now need the Terraform script.
Yes, you can do it. Of course, you can import the resources that you already have in Azure, make Terraform aware of them, and deploy new ones or make changes if you want. This is possible. Yes.
Yeah. It's really good. It's been quite. It's a very interesting talk. This it was. Does
Yes.
make.
Yes. I was afraid of it. I have to tell you the truth. I was not sure about it. I thought that I will fail, but you know, a little bit of persistence, a little bit of patience, and you are there. You don't need to be nothing coder or no. You don't need to be something like that. You will get it.
You know,
Very fast.
When you said there was some issues with the propagation of the how if you were automating this, how would you overcome those problems? Would you just do a second try?
Yes.
Like
yes. You can just.
Could you automate that as well to check for?
Yes, you can automate that. Of course, you can have a script, and if the output is not what you are expecting, make it run again and apply. But if you incorporate DevOps into alongside with Terraform, then you have it. You can do a lot of many things because you can send an API call to your DevOps organization and start deploying and have all these security, or how can I say it, operational um, safeguards that if something fails, just try it again.
Yeah.
Yes.
And
it's like when you're doing it in the portal, you have to log out and log back in, and it's just trying to force the permissions to propagate. So sometimes it's just time, isn't it?
Yes.
Well, thank you very much. That was very good.
It was my pleasure, guys. It was a pleasure for me. Yeah.
Thank you.